Hello there, Mr. Sutton here, bringing you the 2025 MCAS Solutions, Part 2, dealing with questions 22 through 42. For this problem, we have this circle K, and they're telling us the measure of JML, that's JML, this major arc here, is 290 degrees. Based on that, they want the measure of angle JKL. All right, so how do we get to the bottom of this? Well, the first thing to realize is that JKL is a central angle. That means that the measure of angle JKL is also going to be the measure of arc JL, the arc that it intercepts, the minor arc. So that's kind of our starting assumption here. And that means we just have to actually find the measure of arc JL. Well, we know there's 360 degrees in the whole circle. So to find JL, we just have to do 360 minus the major arc, which they told us was 290 degrees. So 360 minus 290 then is going to give us 70 degrees, choice B. For this problem, they're giving us the expression 3x squared minus x plus 4, and they basically want us to sort out, what's the coefficient, the constant, the exponent, and the variable. Just kind of knowing what these words mean. So we're going to go through each answer choice, and we'll just keep going until we can eliminate it or everything checks out. So for choice A, they're saying 2 is the coefficient. Well, the coefficient is the number being multiplied by the variable. So the only coefficient that's really kind of in your face here is this 3. This negative x has a coefficient of -1. And 4, I guess, counts as a coefficient of 4, but none of those is 2. So that's a no, and choice A can't be it. On to choice B. 3 is the coefficient. Well, yes, there is a coefficient of 3. X is the constant. Not so much. X is the variable. That's the thing that could change. So that's a big no. On to choice C. 2 is the coefficient. We already discussed that. That's a definite no. And then choice D has got to be it, but let's just go through and make sure. 3 is the coefficient. Check. Yep. 4 is the constant. Well, here's 4. It's the non-variable, so yes. 2 is the exponent. Yes, that is the power that the variable here is being raised to. And then finally, x is the variable. Yep, they've got x's there. So choice D. On this problem, they want to know which figure has rotational symmetry. So let's go through each of these and see what types of symmetry it has. Choice A has line symmetry for sure. And also, it's got these 5 points that are the same angular kind of distance apart from each other. So that means that rotating this thing, whatever 360 divided by 5 is, 72 degrees, is going to give us the same image. We could just keep rotating it 5 times, and we would get the same image every single time. And we only have to be able to do this once, though. So A is looking pretty good, but let's look at the other choices. So B has line symmetry, but rotating it won't give you the same image. C also has line symmetry, but again, rotating not going to work. If this was a convex rather than concave sort of thing, we might be in better shape there. And then finally D, rotating that is not going to give us anything, but we do have a line of symmetry in there. So B, C, and D, line symmetry only, so choice A is the only one that matches here. For this problem, high school basketball player claims he is 6 feet 6 inches tall. His claim has a measurement error of about 4%. Okay, so based on that, what could be the player's actual height? So essentially, we're trying to figure out, his height. He could be 4% less than this number or 4% more. So it would probably be a good idea to figure out what 4% of 6'6" actually is. So we could be off by 0.04, that's 4%, times 6.5. And let me get out my calculator for that. So we've got 0.04, 6.5, that's 6'6" inches. So that's 0.26. So we could be off by a measure of 0.26 feet. Okay, so I need to add 0.26 feet and subtract it from the original here to get my range of values. Now, what is 0.26 in terms of feet and inches? Because all the answer choices are in terms of inches, so I can't just use this 0.26 in the format that it's in. So if I multiply that by 12 to figure out how many inches 0.26 feet is, let me do that now. So 0.26 times 12, that gives us 3.12. So that's how many inches above or below 6'6" I could be. So on the low end, we have 6'6" minus 3.12, and 6.6 or 6'6" plus 3.12 inches. So this is going to be 6 foot 2 inches, 2.88 inches. There we go. And we're going to be less than 6 foot 9.12 inches. Okay. So let me just check my answer choices now, given this, for something that's in this range. So 6'2", that's less than the 6.2, 6'2.88", so we can't use choice A. 6'3" is just barely in that range, so B is looking good. Let's just check the others to be sure. 6'10" and 6'11" are both higher than this 6'9", so definitely choice B then. For this problem, Kelly graphs a circle on a coordinate plane, and they're not showing any of this. The center is P, which is going to be 0, 0, so it's on the origin. And then Kelly plots a point R that is on the circle, and its coordinates are at -6, 0. Okay, so we have this circle at the origin and some point a little bit to the left of that is on the circle itself. So next, Kelly plots some other point Z somewhere on the coordinate plane. Its coordinates are 5, 3. We're basically asking, based on these answer choices, is this point on the circle, inside the circle, is it outside the circle, and how do we know this? So to figure out whether we're on, inside, or outside the circle, it would be helpful to know what the radius of the circle is. So let's find that first. That's just going to be the distance between the center and one of the points on the circle. The only point we have is this -6, so I just need to find out how far it is from 0 to -6. And this is a perfectly horizontal distance, so we don't need the full distance formula for this. We can just find the difference of the x values, the absolute difference there. So that comes out to a distance of 6. That's our radius. So let's find now the distance from the center to point Z using our distance formula. So that'll be the square root of x2 minus x1 squared plus y2 minus y1 squared. So in this case, that's going to be 5 minus 0 and 3 minus 0 going into our distance formula here. And I don't think this is going to be a nice whole number, so let me use the calculator. This is the calculator part of the MCAS to evaluate this. All right, so I have square root SQRT, and then we've got, we can just write 5 squared, we don't have to write minus 0, and then plus 3 squared, and that comes out to about 5.8 and some change. Now the key conclusion from this, 5.8 is less than the radius of 6. So if it's less than the radius of 6, that means that we are going to be inside the circle based off of that. Now let's look at our answer choices. The only one that said inside was choice B, inside, and let's read the because. Because the distance from point P to point Z is less than the radius. That's exactly what we found here. So let's go with B. For this multi-part problem, we have a ball being kicked from the ground into the air, and the function down here, h of t, models the height of the ball above the ground at any time until it returned to the ground. So let's see here, t is the number of seconds that have elapsed since the ball was kicked, h is the height of the ball, we already kind of knew that, but they spelled it out for us, and then they want us to find the value of h of 0 for part A. Now if you look at the other parts as well, they're going to have you plug a bunch of numbers into this h function, so I think it would make sense to actually write the h function in my calculator, and then I can just plug in whatever I want. So here's my calculator, the scientific part of it, although we have access to the graphing part as well. We don't really need it for this. Let me just write h of t equals, and then -16t exponent 2 plus 80t. And now I can plug anything I want into this by writing h parentheses whatever I'm plugging in. So the first thing we wanted was h of 0. Now if I'm doing the MCAS and showing my work, it doesn't really cost me too much to show what h of 0 looks like algebraically. So really what we're doing is just plugging 0 in for all the t variables in the function. And if we do that, I mean, you probably don't need a calculator to see this. We're zeroing out the first term, we're zeroing out the second term. This should come out to 0, but just to make sure that my function is working as advertised, if we do h of 0, we do indeed get an output of 0. Awesome. For part B of this problem, they want to know which of the following is the value of h of 1. So now we're just plugging 1 in for all the t values there. And you could probably do this without a calculator, but the calculator is available, so once you've written this step, it doesn't cost us too much just to replace the 0 from part A with the 1 from part B, and that comes out to 64, which makes sense. I mean, this would just be negative 16 plus 80, so 64, which gives us choice C. For part C, now they want to know the value of h of 5, so now we're plugging 5 in for all of those t values. And now once I've shown that, I'm definitely going to go to the calculator and just plug that in. I don't feel like trying to do this without it. So h of 5 gives us 0. Okay, so what does that actually mean? They want to explain this value in the situation. So we plugged in an input of 5. That was 5 seconds. And we got back an output of 0. That's 0 feet above the ground. So after 5 seconds have passed, we are 0 feet above the ground, which is basically saying the ball has landed, right? Because if you're at 0, then you're on the ground. Finally, for part D, they want to know the value of h of 6, and then what does that value represent in the situation? So let's go back and plug in 6 now for the h function. Plugging that in, we get negative 96. So plugging in 6 gave us negative 96. All right. So what does that actually mean? Well, it means that 6 seconds after the ball was kicked, it would be 96 feet below the height at which it was kicked, below the initial height. So this would be especially relevant if, say, we kicked the ball off a building. Then height 0 would, you could think of that as like the ground you're standing on top of the building, and then 96 feet below is 96 feet, falling down that building. But they said that we were on the ground here. So since the ball hits the ground at 5 seconds, and we established that in part C, any value after that, including this value, really should be 0 if this is truly following a real-life phenomenon. The ball is not going to burrow 96 feet into the ground. For this problem, we've got a table showing the number of desks of different colors and sizes in an office building. So we could have large and small desks, and also brown and gray ones, so huge variety to choose from here. They've also conveniently totaled these up for us. That was really nice of them. So based on the table, we want the probability that a randomly chosen desk in the building is brown. All right, so we've got a probability of, we want our favorable outcomes over the total number of possible outcomes for this. So favorable outcomes, we're just looking for brown desks. It doesn't matter if they're large or small, we just want them to be brown. So looking in the table here, we have a total of 40 brown desks, so that'll be our numerator. Now what's the denominator going to be? What's the total collection of desks that I'm choosing from? We have to read carefully here. They said a randomly chosen desk in the building. All right, so they're not talking about any specific type of desk, they're talking about the overall total of desks. And that's given by this 120 here that's in the total row and the total column. So 120 is our denominator then. And that's none of the answer choices, so we have to reduce this. This would be 1 over 3, giving us choice C. For this problem, we have a rare painting that was purchased for an art museum, and we have a function modeling the projected value of the painting x years after its purchase. So f of x equals 10,500 times 1.015 to the x. So we've got an exponential function here. Based on this function, we want to know which of the following statements is true. So they're talking about the painting's value decreasing, the value at the time being of its purchase being this value here, or is it projected to increase 15% a year, or is the painting's value after 15 years twice its purchase price? So we're going to analyze this function a little bit, get a little information about it, and then that'll help us pick one of these answer choices. So let me first start with the initial value. In general, we have a function in the format of a times b to the x. We know for exponential functions that this a value here is always your starting value, because if you plug 0 in for x, that basically turns this b to the x into a 1, and all you're left with is this initial a value. So that means this 10,500 is the original value of the painting. So that's our initial value, that a value, 10,500. Now let's talk a little bit about this b value. This b value is 1.015. That is greater than 1. What that tells us, since we're multiplying by this over and over again for this exponential, that means this thing's getting bigger. It's growing with time. It's increasing. So that's going to be important for weeding through these answer choices. And while we're talking about the b value you might know is actually made up of 1 plus the r value, 1 plus the rate at which things are increasing. So since b is really 1 plus r, that means we can think of it as 1 plus 0.015, which means that the r value in this picture here is just this 0.015, which expressed as a decimal, if we just multiply this by 100, this is going to be 1.5%. So this is how much the value of the painting is increasing every year, 1.5%. And then finally, they have an answer choice talking about the value after 15 years. So we have a calculator available. Let's actually find that. So let me go on Desmos, and I'm going to create a function here for f of x. So f of x equals 10,500, no commas used in the calculator here, parentheses 0.015, and then let's raise that to the x power. And now I have something to give me the value after a certain number of years. So like if I do f of 1, it gives me the value after 1 year, f of 2 after 2 years. Let's go all the way to f of 15 and see what we get. So it's giving us 13,127.44 if we round that off. So I just plugged that in Desmos and that's what I got. So that'll help us take a look at answer choice D. So let's go through each of these answer choices now. Choice A, the painting's value is decreasing. Well, we saw here because of the B value it's increasing, so that's not true. Choice B, painting's value at the time of purchase was 10,500. Yep, we saw that right away, so that is true. Painting's value is projected to increase by 15%. Nope, we saw that it was 1.5%. So that's a no. And then this last one should be a no. Painting's value after 15 years will be twice the purchase price. Well, we purchased it for 10,500, and 13,000 and change is not 2 times that, so that's a no. So definitely choice B then. In this problem, they're giving us a triangle, 2 triangles actually, and they're telling us that RST, the big triangle, is similar to RXY, the smaller triangle. And based on that, they want to know what could be the lengths of some of the sides of the triangles. So the key here is to set up an equation that involves all these sides, and we can do that using the knowledge that these triangles are similar. Since these triangles are similar, that means their sides are in proportion. So RY over RT, smaller triangle over bigger triangle side, should be the same ratio as RX over RS. So we just need to basically plug in these different values to this equation and see which one of these actually makes this come out true. So we've basically got first thing over second thing equaling third thing over fourth thing. So 2 over 4 for choice A here, and does that equal 3 over 5? Well, this is 1/2, 3/5 is not the same as 1/2, so that's a no. So these could not be the sides if these triangles are actually similar. So moving on to B then, we've got 2 over 4 and 3 over 6. Those both reduce to 1/2, so this is a yes. These could definitely be the sides. And you could, if you wanted, now pick choice B. Now, if you want to be on the really safe side, you could try these other ones. 2 over 5 and 4 over 7, those are not the same ratio. And then 2 over 6 and 4 over 8, 1/3 versus 1/2, also not the same thing. So choice B it is. On this problem, they want to know which statement about the slopes of 2 perpendicular lines could be true. And we've got all these different statements about the slopes being 0, undefined, 1. So what's the truth of all this? Well, perpendicular lines are lines whose slopes are opposite reciprocals. And just to kind of, draw perpendicular lines here. So here's like one set of perpendicular lines, or at least my attempt at drawing them. They meet at a right angle. So these slopes have to be opposite reciprocals. So based off of that, the slopes can't be the same angle at least. So we couldn't have both slopes being 0 because then they would be parallel, not perpendicular. And by the same token, the slopes can't be both undefined. Undefined with slope really just means you have a vertical line. So we couldn't have two vertical lines either. So now our other options. One slope is 0, the other is 1, or the slope is undefined. So let's start with the assumption that one slope is 0. Let's say m1, slope 1 is 0. The opposite reciprocal of that would be negative 1 over 0. But what is negative 1 over 0? Well, dividing by 0 gives you undefined. So that means that if one slope is 0, the other is going to have to be undefined. Which is to say, if one line is horizontal, the other line must be vertical. So that would be choice D. For this multi-part problem, we're told that it takes workers at a factory 2 hours and 30 minutes to produce 160 umbrellas. For part A, they want to know at this rate what's the closest to the total number of umbrellas the workers can produce in 8 hours. So I'm going to just set up a little bit of a conversion factor sort of a setup here. So I'm starting with 8 hours, and I want to convert that to umbrellas. So what's the conversion factor between hours and umbrellas? Well, I know that 2.5 hours is equivalent to 160 umbrellas. And I want to get rid of hours and get umbrellas. So I'm going to write 8 hours times 160 over 2.5. 8 hours times 160 umbrellas over 2.5 hours. And if I do this, my hours units cancel out. And now I can just multiply all this stuff out. And I have a calculator available, so I might as well use the tools I have. Let me do 8 times, and let me make a fraction, and 160 over 2.5, and that all comes out to 512. Now the closest answer to that is going to be choice C, 500. For part B of this problem, we want to know how many hours rounded to the nearest hour would it take workers to produce 1,100 umbrellas. So basically we're just going to use the same conversion factor before of 2.5 hours and 160 umbrellas, and we're going to change umbrellas into hours now. To do that, I just need to flip my conversion factor upside down. So I need to do 1,100 umbrellas times 2.5 hours over 160 umbrellas. Now the umbrellas units will cancel out, and if I multiply this and crunch the numbers on the calculator, which I'm going to do right now, that should give me my answer. So let me do 1,100 times fraction 2.5 over 160, and that comes out to roughly 17. So 17 hours. On this one, we're shown a circular cylinder, and we've got the radius is r and the height is h. Which of the following, they want to know, describes how the volume of the cylinder changes as its radius or its height changes? And there's two answers out of here. So we're basically asking about the r and the h separately. Although they say select two answers, we probably want to pick one that has an r and one that has an h. Now you'll notice that in all of these choices for the r's, we're multiplying the r value by 3 every single time and just seeing how that changes the volume. For the h's, we're multiplying all those by 4. So our volume formula overall, this is the important piece here, that's going to be pi r squared h, and that is on your formula sheet for the MCAS, so you could look that up if you needed. And because r and h have different exponents affecting them, that's going to change the effects on the overall volume when we do various things to those parameters. So since we have r being squared, since r is second power, that means that increasing r times 3 really means we're doing times 3 squared, because that 3 is going to get multiplied by itself. So this is really a change of times 9 to the overall volume. H, on the other hand, is a first power parameter. So when we do times 4 there, it's really just times 4 to the first power, which is just times 4. So going through our answer choices then, we see that R is going to be increasing the volume by 9 if R gets multiplied by 3, so choice C. And for the H's, if we multiply H by 4, then the volume is 4 times as great. So choices C and D. For this question, we have triangles EFI and EGH, and they are similar. So based off of all that and these measurements here, they want to know for part A, what's the measure of angle E? Okay, well, in order to get E, it would be helpful to know what the measure of angle EFI is up here. And we already know the measure of its supplement, 120 degrees right here. Since this angle and this 120 are on the same line, that means they must add up to 180. So this angle, EFI, is actually going to be 180 minus 120, which is 60. So this is 60 degrees right here. Now, since I've already got 2 out of the 3 angles in a triangle, I can find the third one pretty quickly. And since one of the angles is 90 degrees, to find this third angle, I just need to do the remaining 90 degrees minus the 60 that I've used up here. So 90 minus 60, which is going to give me 30 degrees. For part B of this problem, we're told that the length of EF is 6 inches and the length of IF is 3 inches. I mean, they already put that in the diagram, but again, they're just sort of really spelling this out for us. We want to know the scale factor between the corresponding sides of the triangles. So basically, you just need to take 2 sides that go together, like FI and GH, and see what the ratio between those 2 sides is. So in this case, we've got 3 over 9, which if we reduce it, gives us a ratio and a scale factor of 1 over 3. For part C of the problem, they want to know the length in inches of FG. So my strategy for figuring this out is going to be to figure out the length of EG, which I should be able to do because I've got the side of the smaller triangle and I know the scale factor of the similar triangles. So I'm going to find EG first, and then I will just subtract EF from that to get FG. So let's get EG. So I'm going to set up a ratio. I know that EF over EG has to equal my scale factor of 1/3. And since I'm trying to find EG, I have to plug in something for EF, so we'll just use 6 for that. And now I can cross multiply. That'll give me EG times 1, which is just EG, equaling 18. So just to go back to my original strategy, I'm going to subtract EF from EG to get FG. So FG is going to be EG minus EF. So that's going to be the 18 I just found minus the 6 that I already had, which gives us 12 inches for that length. For part D, the final boss battle of this open response question, they want the length in inches of segment IH right here. So I'm going to follow the same strategy I used to get FG. I'm going to find the length of the entire side, EH, and then I'm going to subtract the length of EI. Only in order to do this, I'm going to have to figure out EI first. So luckily, this is part of a right triangle, and I already have 2 sides, so I can use my Pythagorean theorem to get this. I can say EI squared plus 3 squared equals my hypotenuse, 6 squared. So that means that if I subtract the 3 squared and square root everything, I'm going to get EI equaling the square root of 6 squared minus 3 squared. Now I could do this on a calculator and get a decimal, but I don't really need that level of rounding off. So I'm just going to simplify this a little bit. So this is 36 minus 9, which is going to give me 20, let's see, that's 27, right? Yep. So square root of 27. And if I wanted to, I could simplify this radical a little bit. I could split this up into 9 times 3 and square root the 9. So this could be written, if I wanted, as 3 radical 3. Now, I also need to figure out EH, that total side there, because I'm going to subtract this 3 radical 3 from the total side. Setting up my ratio, I know that the ratio of EI over EH should be 1/3. Again, that's my scale factor that I found in part B. And EI we just found was 3 radical 3. So if I cross multiply here to solve for this EH side, I get EH equals 3 times 3 radical 3, so 9 radical 3. All right, so again, to find IH, I'm going to do EH minus EI. So that's going to be 9 radical 3 minus 3 radical 3, which conveniently gives me 6 radical 3, and that'll be in inches. For this question, which is a two-parter, we have a correlation coefficient that a student got from a set of data, 0.92 for the R value. So based on that, we want to know which statement is true. Is it a weak or a strong correlation, and is it a positive or a negative correlation? Well, 0.92 is a positive value, and it's relatively close to 1, which is the strongest correlation you can get. Since this is positive and close to 1, we would say that this is both a strong correlation and a positive one, so choice C. For part D of this one, they said the student's going to graph the line of the best fit based on this, and they want to know which statement is going to be true about that line. Is it going to be positive, negative? Is the y-intercept going to be positive or negative? So we don't actually know just from R values what the y-intercept is going to be. We don't have any individual points, but we can tell about the slope. So if R is positive, like in this case, that means the slope must be positive. If R were negative, then the slope would be negative. So this is going to be choice A. For this problem, we're told that we have a farm with a bunch of animals. 30% of them are chickens, and 24% of the animals are chickens that lay eggs. So they are both chickens and they lay eggs. So we want to know that given that a randomly selected animal from the farm is a chicken, so given chicken, what is the probability that it lays eggs? So we're asking a conditional probability question here. And we're asking one kind of in the context of a and statement, essentially. So let's name our two events that are going on just to make a little more sense of this and use our formula. So we've got event A is the animal is a chicken, and let's let B represent the animal lays eggs. So we know that the probability of A and B being true is going to be the probability of A, the probability that we're a chicken, times the conditional probability that we lay eggs given that we are a chicken. So probability of B given that A's already happened. Okay, so let's put all this together now and plug some things in. The probability of A and B, that's the probability of basically this 24%. 24% of the animals are chickens that lay eggs. You're meeting conditions A and B at the same time. So that's going to be 24 over 100, I'm going to write that as. And now probability of being a chicken is 30%, so I'm going to write that as 30 over 100. And we're still looking for the probability of B given A. That's this question they were asking here. So in order to get this probability, I have to divide by 30 over 100, which means I'm really just multiplying by the reciprocal, 100 over 30. So in this situation, this is actually kind of convenient. These 100s are going to cross cancel. So this just gives us 24 over 30 for the probability of laying eggs given that we're a chicken here. So that's going to be choice B. On this problem, we have a whole bunch of words and diagrams, and when you see how straightforward this one is, actually, you're going to be like, why did they have all these words? So we've got point P on circle T as shown here. And a student uses a compass and a straight edge to perform a geometric construction. First, they set the compass equal to the radius of T, great, and then they use the compass to draw 6 consecutive arcs along the circle, starting at point P as they shown here. So this is down here. These are the arcs that they've shown here. And then the student drew a point at each intersection of an arc and circle T. And finally, in a clockwise direction, starting at point P, they used a straight edge to connect line segments to the consecutive points around the circle. So they did basically this sort of thing here, where they connected all these points that they would have drawn at the intersection of these arcs and the circle. So which best describes the student's completed construction? This is one where you really literally just have to look at what you just drew here. So it's not a square, it's not 4 inscribed triangles or 2 inscribed trapezoids. It is just an inscribed regular hexagon. That is it. Choice D. For this one, Alfredo graphed congruent pentagons J and H on the coordinate plane. And we want to know if he performed a sequence of transformations on pentagon J to get pentagon H, what were those transformations? What could they have been? Because there's an infinite number of possibilities, but only one of these options is going to work. So what I'm going to do is I'm just going to go through and actually perform each of these and see which one gives me image H. So let's start with choice A, reflection over the x-axis and translation 4 units left. So over the x-axis, that would reflect down here, and then 4 units left would take me 4 left like so. This is what I would end up with for the new pentagon. So that would be choice A, which doesn't match what we wanted. For choice B, reflection over the x-axis, so same as before, and then 8 units down. I don't have enough space to go 8 down, but we would end up somewhere down here, which again is not what we're looking for. Next, reflection over the y-axis and 8 units down. So we're reflecting this way and going down 8, which if you count squares carefully would actually bring you to this H pentagon here. So that would be choice C. That's looking pretty good. And the only other option is reflection over the y-axis and then 4 units left and 8 down. So that would bring us like over this way, which is a little bit off from what we need. So choice C works the best. For this one, we've got a two-parter. First part, we want the volume rounded to the nearest cubic centimeter of this first cylinder they've drawn for us, cylinder E. So the volume of a cylinder in general, that's going to be pi r squared times h. Again, that's something you can look up on the formula sheet. And we're basically just plugging in the r and the h values here. So we've got pi times 10 squared times 20. And we just have to plug that in and round it off. So going ahead and doing that, let me write in pi for pi, or you could just write 3.14. And then we're doing 10 squared times 20, and that's approximately 6,283 cubic centimeters. For part B, they're telling us the area of the base of cylinder E and cylinder F are the same total area, and they want to know which statement correctly compares the volumes of the two cylinders. So we've got them being equal or not equal. That's one way of splitting the answer choices. And in all of these, they're talking about it's equal or not equal because the heights are equal or because the slant heights are equal or not equal. So the general rule of thumb, actually not rule, law of geometry, is when you have one of these solids and you kind of tilt it a little bit and shift it like this, you actually don't change the volume of this. In general, the same height is going to give you the same volume. And the intuition behind this is if you think of these as like a stack of pancakes, right? Here's my original stack of pancakes, and if I push on that stack a little bit so that it's kind of the leaning tower of pancakes here, I haven't changed how much pancakiness is in there. I haven't changed the volume of all those pancakes. I've just kind of changed, the angle at which they're sitting on each other. So same height, same volume. So looking at our answer choices, choice A, volume is equal to the volume of F. Because the heights are equal, that's exactly what we just set up here. So choice A looks like a good answer. But let's just look at these other ones. So B, volume is equal because the slant heights are equal. And that is not necessarily true. It's all about the actual bottom to top height. So that's a little bit off. And then C and D are both wrong by the simple fact that they're saying these are not equal volumes, and in fact they are. So choice A. For this problem, we're given a system of equations, and we're told that a student will solve the system by creating this equivalent system of equations, where A is an integer. So if you look at this, the first equation is the same in both systems, but the second equation has changed a bit. Now instead of 5x plus 4y equals 2, we have negative 10x plus something times y And that's what we're trying to figure out. The value of a, the value of the something, equals -4. So we essentially have to figure out what did the student do to create this alternate system. Now, the logic behind what the student was probably thinking is, with this system the way it is, I could now add these two equations together and cancel out these 10x's. So this is using the elimination method. Now, in order to do that, we couldn't do it initially because we had a 5x, not a -10x. So we had to multiply this second equation by something that would allow us to cancel out those x's. What did we multiply by? Well, to get from 5x to -10x, you would have to multiply by -2. So if we just multiply the 4 here by -2, that'll tell us what the new a value has to be. So -2 times 4 is going to give us an a value of -8. On this problem, we've got two rectangles and a point Z, and we're told that this bigger rectangle here is what happens if you dilate this smaller one with respect to point Z. So basically that means that however far apart horizontally and vertically each point from this first rectangle is, we're going to multiply all those distances by some number, and that's going to give us the location of these new 4 points that we drew here. So based off this, we want to know the scale factor that we used to make this happen. So as just a general strategy, I'm just going to figure out the original distance between one of these points and point Z. I'm going to figure out the distance between Z and the new version of that point, and then I'm just going to see what I would have to multiply by to get that distance. And it doesn't matter if you use horizontal or vertical distances, both the x and the y end up getting multiplied by whatever the scale factor is. So I'm just going to go with horizontal distances. So my horizontal distance, I'm going to go from just q to z because that's the easiest to pick out here. That's going to be 9 minus 4. So that's my x distance from z to q, and that's a distance of 5. Now how far is it from z to q prime, which is the image of q? Well, that would be 9 minus -1 would give me that distance. So that's going to be a distance of 10. So we've got 10 divided by 5, that's what my scale factor is, that's what I have to multiply by, and that reduces to 2, which leaves me with answer choice A. For this problem, they're saying as the x value of a linear function increases, the y value decreases, which describes the slope of the graph. And we've got 0, positive, negative, or undefined. Okay, so let's translate this. If the x values of a function are increasing, that means we are moving in the positive direction on the x-axis, which means essentially we're moving right. If the y value is decreasing, now we're moving on the negative direction of the y-axis, which basically means moving down. So if we have a function that is going right and down at the same time, that's like this direction here, that's going to be a negative slope. So choice C.